So today we're going to talk about projection. So in terms of projection, we want to talk a little bit about orthogonality. So we say that u and v, two vectors, are orthogonal if their dot product equals 0. This is due to the formula of the dot product. Yeah, we'll discuss that in a minute. But 0 vectors are orthogonal to every vector, so the dot product will equal 0 with any vector because a 0 vector is simply a point, so it'll be orthogonal or 90 degrees to every vector. And the standard unit vectors e1, e2 are orthogonal to each other because they are placed on the axes. So projection, just a definition. So projection is essentially a function which will place another function onto a line. So if A is a real non-zero vector and U is any real vector, then U can be decomposed into the sum U equals W sub 1 plus W sub 2, where W sub 1 is a scalar multiple of A, parallel to A, and W sub 2 is orthogonal to A. So just looking at a representation of the projection, we have U being the vector, which is projected onto A, another vector, in terms of W sub 1, which is parallel to A and is a scalar of A, and W sub 2, which is orthogonal to A. So the equation for this is W1 is equal to U dot A over length of A squared times A, which is just the notation is projection of U onto A, which is projection sub A U, and W2 is U minus that projection of U onto A. So fairly simple. We'll just do a quick video example projecting U onto A here, just giving these vectors some numbers. And as an extra example, we're just going to review how to use the dot product to find the angle between these two vectors. But for now, we'll just use the projection. So U equals 2314, and A equals 1225. And then we're just going to use that formula. So to find W1, that's equal to U dot A over length of A squared times A. So this will be equal to 2314.1225 over square root of 1 squared plus 2 squared plus 2 squared plus 5 squared, all squared, times 1, 2, 2, 5. So we'll go ahead and do the dot product. So 2 times 1 is 2, plus 6, plus 42, plus 20, all over root. I guess we can get rid of the root. It would just be 1 plus 4 plus 4 plus 25. This would all be multiplied by 1, 2, 2, 5, which is A. So this is equal to 2 plus 6 plus 2 plus 20 is 30 over 1 plus 4 plus 4 plus 25 is 26 plus 8, which is equal to 34. Just want to verify that. 34 times 1, 2, 2, 5, which is equal to 30 over 34, 60 over 34, 60 over 34, and 150 over 34. So that's W1. And then, as we saw here, W2 is just equal to U minus that. Sorry, I should have those arrows there to indicate that they're vectors. So U being 2, 3, 1, 4. Minus so I'm not going to do the math, but it would be fairly simple to do that. So you can then find W1 and W2, and that is how you find the projection of U onto A. Thank you again to Loom and Google Keep, and as well to my professors who taught me this. And I hope this helps, and we'll see you again soon. Thank you for watching.